Hello and welcome to the webinar Quantitative Text Analysis for Social Scientists, a presentation by Nicole Baerg of the University of Essex. My name is Michael Todd and I'm the Community Manager of the Methods-Based website. So let me start by introducing you to our guest, Nicole Baerg, for today's webinar, which is the first from SAGE's offering of computational social science online courses known as SAGE Campus. Now, Nicole, originally from British Columbia, is a lecturer at the Department of Government at the University of Essex, and her research areas include the political economy of central banking, fiscal and monetary policies, public opinion, and immigration. She is interested in political textual analysis and helped develop the Political Text Analysis Network at the University of Mannheim, where she was an assistant professor before coming to Essex. She remains affiliated with Mannheim's Collaborative Research Center, Political Economy of Reforms project. Here at SAGE, Nicole is a subject matter expert for our SAGE Campus Quantitative Text Analysis course. Speaking of that course and of the other online courses offered through SAGE Campus, today's webinar audience is being offered a big discount, 50%, for any of these course offerings. You can learn about the offerings at the campus website, campus.sagepub.com, and make sure you have this code, QTAWEB50, think of it as Quantitative Text Analysis Web 50, at the ready. We'll repeat that code, QTAWEB50, again at the end, and it should be on the screen at various points during the webinar. Now, this 1 hour webinar will be recorded and archived for future viewing, and we'll be sending out a link to view it in the coming weeks to registered participants. Now, if you have any problems with audio or viewing mode during the webinar, please use the Q&A box on the right of your screen, and one of our helpful team members will get back to you ASAP. So let's start the conversation. Nicole will talk for about half the event, and then we'll open up the floor to questions from you, the audience. And please use that same Q&A box to ask questions to the speaker throughout the webinar, even though we won't be getting to them immediately. You can also leave comments there or tweet us using the hashtag SageTalks hashtag. Now, Nicole, are you ready to go?
Hi, everybody. So what I'm going to do today is talk to you a little bit about quantitative text analysis. The purpose of my presentation today is to go over an overview and some of the fundamentals behind the course that you're potentially going to do with my colleague later on. So the first part I'm going to talk about is just what do we mean when we say text is data. So in terms of the learning objectives for the course, and then also today, we're going to spend a little bit of time talking about why text data is different from other forms of data that you might be more familiar with, such as numerical information. We're going to also talk a little bit about how text data is the same as other types of data. And finally, we're going to spend a little bit of time talking about what tools we need in order to treat textual information as data for statistical modeling, as well as some potential pitfalls. So first, let's talk a little bit about what quantitative textual analysis is. So quantitative textual analysis is a variant of content analysis that is expressively quantitative in nature. So what this means is that it's not just in terms of representing textual content numerically, but also in analyzing it. So what we usually do is take textual information, come up with some sort of numerical schematic to represent that text, and then use sort of more traditional computational and statistical methods in order to come up with some sort of statistical model of inference that we can make. Mild forms of textual analysis reduce text to some sort of quantitative information and then analyze this information using some sort of quantitative technique. So for instance, this has a long history in social sciences, such as looking at what proportion of the text talks about the economy, or what proportion of the text talks about social policy, for instance, and then using those types of quantitative information to help us get an understanding of potentially how social groups or parties or organizations might care about different topics. Today we're going to focus on what's considered to be a more extreme form of textual analysis, and that means that we're going to actually use the textual elements as units in data, as sort of information that we use as data directly for the analysis in some sort of statistical or computational way. So why we are now turning to this type of informational processing rather than sort of previous processing relates to a kind of supply of information that's become available to us as the volumes of text in the last little while have been increasing. So this is both increasing in terms of the kind of textual information that we ourselves supply by way of Twitter posts or Facebook posts or things like that, but it also has to do with the actual making historical archives of textual things such as Native American treaties, international organizations, bilateral investment treaties, machine readable. And so the amount of data that we have that comes in textual formats has been increasing quite substantially, and so we want to figure out if there's some way that we can take that unstructured data, give it some sort of structure, and then use it in our kind of more sort of traditional statistical and computational methods. So in terms of the social sciences, this development or this processing of textual information as data is an emerging field with many new developments. It's at the forefront of interdisciplinary work between computer science, social sciences. And it's very exciting and often referred to as text as data. So now that we kind of know what textual data or quantitative textual information is, I also just want to spend a little bit of time focusing on what it's not. So it's not discourse analysis, which usually is concerned with how text as a whole represents some sort of social or political phenomenon. It's not a social constructivist examination of text. Social constructivists are normally interested in trying to come up with how society is constituted. We're not really thinking about that. It's not normally used in terms of rhetorical analysis, which can focus on how messages or textual information are delivered stylistically by the author or the writer. However, textual analysis can be used this way. For instance, there's a paper in political science by a colleague of mine, Arthur Sperling at New York University, and he has a paper that looks at as the enfranchisement of the vote in the United Kingdom increased, then what you had was members of parliament speaking using stylistic, using more common language so as to appeal to a broader constituency. So in that sense, you can use stylistic interpretations of text to get at some sort of interesting social or political phenomenon. It's also not ethnographic studies, which are normally used to construct narratives around the text or to discuss their meaning. That is what they really say as opposed to what they actually say. And it's also not any procedure that can't be replicated. And by that, what we mean is text as data, at least in the format that we're going to be thinking about it, is some sort of set of procedures that the researcher themselves conducts, and then including both structuring the data and then running the analysis. And the goal is that that process could be replicated by somebody else. So what does basic quantitative textual analysis do? Well, what it does is it takes text, such as these text boxes that are on the left-hand side of the screen. It then converts that textual information into what's called features. In this case, in the top right-hand side, what you see, the features are words, so they make up the columns. And inside of those columns are the number of times that that word is used in a given text. So the first row says T06_Kenny_FG, and you can see that in that document, the individual or the speaker or the document has said made 12 times, because 11 times, had 5 times, into 4 times. And we use covariation across words and across documents to do a number of things. So we can use this kind of textual representation, which is often referred to as a feature matrix. So we have a matrix of features. In this case, the features are words. and inside the words are the frequency or the number of times that that word is used. And we can use that information in this matrix to run a bunch of different kinds of statistical or computational analyses. So for instance, we might want to describe the types of words that are being used by the speakers or across the documents. We might also want to do sentiment analysis. We might want to classify documents on the basis of similarity or dissimilarity, or we might want to actually scale documents showing those that are relatively more similar or less similar than other ones as well. So in order to come up with this document frequency matrix, it requires a number of assumptions, and so I just want to talk a little bit about what those assumptions are. So first of all, in order to think about representing text quantitatively, we must believe that the text itself represents some sort of observable implication of some underlying characteristic that we're interested in. So in political science, oftentimes we're interested in the ideology of the party or the ideology of the member of parliament. In my own research, I'm often interested in the inflation inversion of a particular central banker, given the inflation aversion of his or her colleagues. So there's some sort of underlying latent dimension that we're interested in, and we think that the text itself, the linguistic features that are written down or spoken out loud, gives us some sort of observation on that underlying latent characteristic. We also think that that text can be represented in a valid way through extracting features. As I showed you in the previous table, the most common feature is bag of words. So this means that we're interested just in the frequency with which somebody uses a given word. However, it doesn't just need to be words. We might also be able to think about other kinds of features or important input variables, such as the name of particular entities, like people or places or things. We might also be interested in parts of speech. So that would include things like whether it's a noun or a verb or an adjective. So there's a number of different ways we can think about features, but generally speaking in this class and in the class that moving forward, the most common assumption or the most common way that we're going to process or structure text has to do with the number of times that certain words are used. And as I showed you visually in the previous slide, all of these words and the count of these words can then be organized or structured into what's called a document feature matrix. And from that document feature matrix, we can then use sort of more standard methods or computational methods to produce meaningful and valid estimates of that underlying characteristic or latent thing that we're interested. Again, whether that be the ideology of a party or a person or the relative weight that somebody puts on one objective versus another. Okay, so the next thing I want to talk about with you now that we sort of have an understanding of how we take textual information, structure it in such a way that it can be used in numerical computational approaches, I then kind of want to talk to you a little bit about text as the new frontier of data. We have lots of it. It's on the web. It's in real time. It's in historical archives. Your libraries are constantly spending time and energy, as well as governments are spending time and energy making things electronically available in a machine-readable format. These types of documents are often come unstructured, i.e. they come in written or oral formats that need to be harvested, and then from that harvesting, they need to be put into some sort of structured format such that they can be modeled. In the social sciences, for example, politicians give speeches, political thinkers and revolutionaries write articles, international states and nations sign treaties with each other, such as trade treaties or bilateral investment treaties or treaties on immigration or treaties on debt and deficit spending. And then, of course, voters connect on Facebook, on Twitter, et cetera, et cetera. And so all of these types of forums provide some sort of textual information which needs to be, again, structured, and then from that structuring can then be used as inputs in quantitative social science processes. So this course is going to introduce you to quantitative text as data, and then you're going to think about how you might want to apply this kind of textual information to learn something about some sort of social scientific phenomenon that you're interested in. So in terms of the course more specifically, some of the things we're going to think about is descriptive inference. So how can we characterize text? What sort of words do they use? How do we represent text using this kind of vector space representation? So in the case of the matrix format, how do we put words into a matrix? We're going to think about collocations. This refers to words that occur naturally together. So in central banking, for instance, we might think about the word such as the federal government might also occur with other words such as the Federal Open Market Committee, which is the committee that governs interest rate changes in the United States, is the central bank committee. Or we might also think of other words that might naturally occur together, such as White House or President of the United States. We're going to think about bag of words approach. So this is thinking about features as being individual words. We're also going to think about how we can look at similarity or dissimilarity across speakers as well as across documents. And sometimes we're even going to think about similarity or dissimilarity within even a same given document. We're going to think a little bit about lexical diversity, which is the extent to which you actually use different words. Of course, you could think that a presidential inaugural speech is probably more likely to have more diversity in terms of the word it uses than, say, Twitter, which is something that actually forces you to speak a little bit more clearly and with a shorter number of words. We're also going to think about complexity, so how complicated is the text that we're reading, which again might be a function of what audience are you speaking to. And then finally, we're going to spend a little bit of style, although most of our attention isn't going to be on that. So in terms of when you're actually going to go out into the world and try and perform quantitative text analysis, there's a couple of things that you need to think about. So first, you need to think about selecting the text that you're interested in. So the computational linguistics community often refers to this as defining a corpus or a body or set of text that you're interested in. Secondly, once you have that corpus or that body of text that you're interested in analyzing, as I mentioned previously, you have to take that text, which is in relatively unstructured format, and to convert it into some sort of common electronic format that, that the machine can read. From then, what you want to do is try and figure out, okay, what's my unit of analysis? Am I interested in what an individual speaker said? And am I interested in at the whole document level? Am I interested in analyzing at the paragraph level, at the sentence level? So you have to try and think, what's my particular unit of analysis, which is, of course, a reflection of what it is, the research project that you're trying to pursue, or the inferences that you're trying to make. So in terms of some of the features that we might be interested in, we've already talked a little bit about words, so that's something that we might be interested in. Instead of using words in their entirety, we might also be interested just in word stems or in word lemmas. So this is the idea of creating some sort of equivalent classes for word features. A common example of stemming words would be to get rid of either prefixes or suffixes. So the word investigating would be the same as investigated and investigate. So you would get rid of those endings, and then the count of those three words would be 3 instead of each of those words just being counted once in the document. You might also be interested in word segments. So some languages, such as German, use compound words, and you're not actually interested in the entire word and the frequency of the entire word occurring, but rather you're interested in the actual segment of the word that matters. So for instance, Rindfleisch or something like that. Some other words, some other languages, such as English, actually use white space delimiters between words, so that word sequences are delimited with white space, but other languages this doesn't actually occur, such as in Chinese. In addition to words, you might be interested in linguistic features such as parts of speech. We already talked a little bit about proper nouns, or maybe you're interested in just explaining adjectives. And if what it is that you're really interested in could benefit from a little bit of human coding, you might actually only be interested in those things that you yourself annotated in the text that you think are important. So once you have your document or your unit of analysis and you've selected your features, then what you need to do is you need to convert those features into some sort of quantitative matrix. So a quantitative matrix is just, as we saw before in the case of words, it could be the number of times the word exists in the document or in the sentence. It might just be a binary, does it exist or not exist, or it could be the actual frequency with which it exists. So once you get all of those, once you decide on the features and you've decided on the unit of analysis, then what you have to do is put all of that into a matrix, that information. Once you have that information, because it's quantitative, we can then go on and use various different kinds of statistical procedures to extract information from that matrix. So you could run regression analysis, you could run some sort of measurement model on that information. And then from that, what you're going to do is try and summarize and interpret the results from that statistical procedure. So here's some examples. The first example is an example of textual analysis that I didn't do, but that actually Amazon did. So I looked up Dan Brown's Da Vinci Code on Amazon, and it gave me a comparison of what was happening in the Da Vinci Code compared to other books. So the first dimension that it compared it on, which is something we're going to look at in the class, is its readability. So here's a bunch of different measures of readability, and then it tells me, okay, 80% of these books, according to this index, are actually harder than the Da Vinci Code. 75% are harder, 79% are harder. So it ranks this book compared to other books in terms of its readability. Another dimension that we could think about this book, comparing it to other books, would be its complexity. So often complexity is determined based on the number of syllabuses in the word, as well as the number of words per sentence. So in this case, we find that 66% of other books out there tend to use more complex words using one particular measure, all the way up to 81% if we look at the number of words per sentence. And again, we could also just sort of characterize or describe the Da Vinci Code based on the number of characters that are used, based on the number of words that are contained in the book, or based on the number of sentences. So here's just another example of how you might compare cross text once you do this kind of processing. So here's a case where in the darker gray, we actually have a more academic book called Innovative Methods for Policy Analysis. The second book is the Da Vinci Code from the example slide below. And the third book is Dr. Seuss' The Cat in the Hat. So of course, we can then look at these different types of comparison measures across these three different types of texts. So if we look at readability, that is how difficult is it for somebody to read these books, perhaps unsurprisingly, we find that Innovative Methods for Policy Analysis is much more difficult to read than The Cat in the Hat. If we look at other types of metrics, such as the number of complex words, the number of syllables per word, as well as the number of words per sentence, we see the similar kind of trend. So what we can kind of infer from this analysis is that Dr. Seuss is probably the easiest book to read, with the shortest number of sentences, as well as the least number of complex words. Whereas the other two books are a little bit more difficult. When we go and apply this to political text, we might also determine something interesting about the audience to which the individual is speaking to. So these are two examples of inaugural addresses that the U.S. president makes. So this is Bush's second inaugural address, and this is Obama's first. And in this case, the size of the word is a function of how many times that word is used. So with larger scaled words, this is the president the former president discussing but using this word more frequently. So here we see that Bush's inaugural address focuses mostly on freedom, America, liberty, nation, move, choices, tyranny, fire, excuse. Alternatively, Obama's inaugural address also deals with the nation and America and the people, but it focuses significantly more on work, generation, jobs, the crisis, women, and the ability to endure, perhaps hard times. This next slide is a slide from a working paper that I have with a co-author of mine, Will Lowe, where what we do is we use textual information on statements made by central bankers during committee meetings to try and figure out what proportion of time that they talk about inflation compared to other topics, in particular unemployment and output, and we use that proportion of inflation over those other topics to actually scale them on some sort of common dimension. So if you look on the left-hand axis, on the y-axis, you see a number of names. So this is the second name from the bottom is the former chairperson, Janet Yellen. We score her as being relatively left-leaning on inflation or dovish on inflation compared to previous chairman, which is Ben Bernanke, who is the fourth person from the bottom. In order to see whether or not our text-based positions, so the positions that we come up with for these actors based on the things that they say in committee meetings, provide us with any sort of similarity with how we might rank these people's inflation aversion if experts were to do the placement, we actually compare our measures with expert placements, which is what you observe on the right-hand side of the scale. So experts place these people on a scale from really dovish on inflation all the way to very strong on inflation, so from a strong dove to a strong huck. And by looking at that graph, you can see that for the most part, we recovered the same type of estimates as the expert placement, with the exception of a couple of people. So with ex-chairman Ben Bernanke, we put him slightly more to the right or inflation hawkish than the expert placement. And for President Fisher, we put him slightly, much more to the left than experts had placed him before. In addition to thinking about central bankers, we could also think about political parties. So here's some work from John Sleepin, who's the instructor for this course, and his co-author Ollie Prosch in a paper that was published in the American Journal of Political Science. And here what they're doing is they're trying to look at party placement, so how left or right are political parties in Germany, based on their party manifestos, so based on what the political party itself says about itself. And here we see them scaling left-right party positions in Germany over time, in this case between 1990 and 2005, and they do a bootstrapping technique to actually get uncertainty estimates around those positions, and so you can kind of see how parties have changed positions over time, going from left to the right. So everybody's sort of converging to the middle according to this graph. Okay, so why the social science and computational social science? So a lot of this comes naturally from the computational linguistics community, the computer science community, the people that work on natural language processing. So what do we gain by having a social science approach to this type of textual analysis? So one of the things that I think that social science brings to this type of activity is that it really gets you thinking about the appropriate population of interest that you're interested in thinking about, as well as issues to deal with sample selection. So for example, in the case of the central bank committees, do we want to look at all members of a central bank committee, or do we only want to look at those that have voting power, who matters for our sample, that kind of stuff. In terms of selecting documents, we also want to think about, in terms of a stochastic view of text, or sort of where utterances by a given organization or individual is actually a possibility in what could otherwise be other sort of statements that that speaker could have made. What we're really interested in here is how to get an appropriate sample of speeches by that particular individual. In terms of thinking about feature selection or feature representation, oftentimes our theoretical models are the places that tell us what's important in terms of looking at the text itself. So when you go to exactly how to aggregate or to mine or to model the observed data that we have, we really need to be able to marry those choices with some sort of theoretically driven data generating process that we have in our mind. And so it's the combination of strong theory and then computational approaches that really lead to good, high quality social science research at the end of the day. Also, we want to think about statistical choices. What can we infer about the latent variables that we're interested in? And then, of course, once we get some sort of estimate or some sort of outcome from those statistical models, we want to think about how do they compare with things that we know from previous methods, such as what I showed you with comparing with experts. Alternatively, do they predict the types of things that we might expect them to predict, and how do we validate those measures? So just for example, there's definitely a problem when we think about selecting those texts that are available rather than selecting the texts that are actually important for doing the kinds of research that we're interested in. So a driving force for many projects is just the availability of the data set. So a standard kind of workflow is that researchers discover some data set, they then develop a workflow, a measure of interest, and a research question from given that data set. But what we hope to do in the social sciences is rather come up with a research question first, come up with some sort of idea about what it is that we're interested in or what's important to study or where the hole is in the literature, and then from that try and come up with, okay, how can we get a representative sample of the data that is interesting. So the problem with the data first approach is that it can propagate issues related to bias. It can be related to issues that are also to do with sample selection. So maybe we don't observe data on, hidden or hard to reach communities. The people that talk on Twitter, the people that post messages on Facebook are a particular type already, and so we don't actually have a random sample of individuals that we're interested in. So in order to protect from those types of possible pitfalls in terms of generalizable inferences that we can then make about a larger sample, a larger sort of population, what we need to do, and I think where the importance in social science comes in, is to prioritize these vital social science questions over the data availability. And as a result, sometimes you might want to include something that the theory tells you is important, or you might want to actually code something, or you might want to annotate some text in a way that you think is useful. And so I definitely encourage you, rather than just going out and downloading what's available, to consider creating your own artisan data. So what is it that you actually want from this text? How can you select the texts that you think are important? And then how can you make this curated data? In addition to that, I just wanted to point out some sort of other things to watch out for. So when computers learn from human writing, they actually absorb a lot of the implicit biases that we ourselves as individuals have. So there was a recent paper that was published in Science magazine, in the Journal of Science, that shows that machine learning algorithms that learn from text actually begin to learn how to associate certain different types of occupations with men and other occupations with women because it adopted the biases that humans ourselves have about race and gender. So just because you're using a machine learning approach doesn't mean that that's an impartial or an unbiased view of these types of things. If the machine is actually doing what it's supposed to do, which is to learn from humans, if the humans are biased, then it's likely that the machine will also learn those biases. So that's something to watch out for. In addition, it's also important to think about what kinds of population it is that you're trying to make inferences about. So just because you have a lot of data doesn't necessarily mean that you have good data on minorities. So if somebody in your data is less likely to occur in that data because either they're an ethnic minority or they're just less likely to talk, they're more introverted, stuff like that, then by including just more data, you might not actually end up with a data set that has enough power to actually represent what it is that you want to learn about them. So I definitely encourage you, especially if you're interested in things about minority groups, to think about, how might you select text in such a way that you actually oversample from groups that might be relatively underrepresented, even in big data. So that's something else to think about. So thank you very much.
Thank you so much, Nicole. We're going to now turn to questions from the audience. And please use that Q&A box on the right side of your screen, although actually on my screen it's on the left side, but to ask questions. And you can also use the webinar hashtag #SageTalks to send questions via Twitter. And so, Nicole, we have a kind of a split in the questions that have come in so far. About half of them are on the course itself, and about half of them are on kind of the general issue of quantitative text analysis. I'm going to jump to one that's on the larger issue, because I want to leverage off what you were just talking about. So you were talking about some of the operational pitfalls just now about introducing bias, or perhaps even not even realizing there's bias. But what are some of the central ethical issues in general about this kind of research?
In terms of I think it boils down to being very humble about what it is that you're doing, and then also being humble or being skeptical about the validity of your findings. So I think it's always best to, if you want to draw some kind of inference about something, so say I find that, I don't know, here's an example. So in the central bank literature, there's a finding that women who are appointed to central bank boards can oftentimes be more inflation hawkish than their male counterparts. This is a finding in the literature. So you want to think about, okay, is that something really about the sample that I have? Was that something about the selection of candidates given the types of meetings that I have at my disposal that have been archived? Or is that a general characteristic of women at large? So I think it's up to you as a researcher to try and think about, what is the relevant inference that I can draw from my findings, and to actually be quite humble about what that is, and also to be open to being challenged, and to have data that comes up or other researchers come up and actually find, your previous results weren't true. And I think that's how, I don't necessarily think science is always self-correcting, but I do believe that through, issues of replication, issues of making sure that you're humble, trying to run results with other samples, thinking about these issues in a really kind of critical way, it will lead to, better inferences overall in the long run, I think. Hopefully that answers that question.
Yeah, and I'm going to move from the conceptual to the mechanical right now. Immediately after you stopped speaking, people had, with a single voice, had a big question. What software do you use? And I have a slew of individual questions about that. So I'm just going to ask you if you could, what programs are available, what software do you use for different aspects of, like, say, for extracting text? Can you use R? Can you use in vivo, et cetera? So I'm wondering if you could discuss that, not at inordinate length, but at some length.
Sure. So, so the course is going to be using R. So R is actually, sometimes I think a lot of people think that R is too slow for doing text analysis. You need other kinds of programs. That's certainly true. You can use other kind of programming languages. So Python is another kind of programming language that is used for textual analysis. Perl used to be used for textual analysis, but this course is primarily going to focus on R. So we're going to show you how to do text analysis in the language R, which the nice thing about R is that it's a statistical programming language, so it has a lot of the great statistical packages that are made by users of R around the world. And then inside of that, the course, we're going to focus on a particular package that's been designed by Ken Benoit and some of his colleagues at the London School of Economics, as well as some other people that have been involved with that package over the long term, and that's called Quantitative, so Quanteda. The Quantitative package is quite powerful. It'll do some of the things that we're interested in, such as computing readability, computing collocations, putting your documents into this document frequency matrix. So some of the stuff that I talked can easily be done in R. In terms of downloading data off the website and, web scraping, I mean, that's not necessarily going to be covered in this course, but there's also tools in R that can do that, and there's, I'm sure, a number of great resources out there that can teach you how to do that. And normally what you want to do is you want to have your files in some sort of text format, not in PDF, but actually in a text format, or you want something like JSON or one of those types of file formats.
Which then brings up another question we have. What are some of the limitations when working with older text? And the specific example that the questioner had was such as 19th century newspapers.
Yeah, so you mean in terms of the readability, if you have like spaces or if, certain characters haven't come through in the actual electronic processing of the data?
Yeah,
so,
and well, you had said that things needed to be machine readable, and then these are things that by their nature are maybe are machine readable in one sense, but in another sense it's like, well, that's a pain, and maybe I don't necessarily have the necessary expertise, so what do I do?
Right, so I mean, so there's kind of like a number of dimensions to that question. So the question is not, so there's two things to think about. So one of the problems with data, especially historical data, whether it be text or like other types of data, is issues of data quality, right? And so you have issues of data quality if you have numerical data, and you have issues of data quality if you have textual data. The issues might be slightly different, but you have issues, in both cases. The second part of the question is, which I think is specific to any kind of pre-processing, but is especially important with textual analysis, is how do I take this unstructured data, right? In this case, it's like paragraphs or sentences or documents or whatever, and put it into some sort of structural format. Some things that you can do, if you know, are specific pitfalls, so that, there's a bunch of spaces or not all characters are correct or something like that. You could maybe use regular expressions. So instead of looking, you could come up with like the whole words, or you could try and do, you could try and think about ways that, I don't know, say things were in one language, and so yeah, like accents or things like that are lost, and then you have to kind of insert them in. So there might be a lot of data cleaning. I think that's true of most people working in this field. So oftentimes we show you what the outcome of once we have the text into the table, but the actual data wrangling part occurs kind of behind the scenes. And I think that's just something that researchers will continue to struggle with until, our kind of OCR reading gets better, or, I mean, that's both technical problems that, hopefully will continue to improve over time.
So here's a kind of a general question about text analysis. Lots of text analysis seems very context specific, and results could be different based on the process you decide to use. So what would be a good practice to generalize your findings?
Context specific in what sense? Like in the sense that so there's kind of, again, two answers to that question. So there are things that you can do if you think that context, if by context what you mean is the words around other words matters. So, so in that case, instead of just thinking about a bag of words approach or a unigram approach where you only consider the frequency of a given word, you also extend that to sequences of words. So, for instance, I think I used the federal government and the Federal Open Market Committee and the federal funds rate. So instead of counting just federal 3 times, you might want to use those words in a string of words to help you get at context. So that would be taking what's called an n-gram approach. So you allow for sequence in that way. If what you mean more is that if the results are sensitive to a particular measure, say the measure that you use of similarity, and that you find that, the same measure doesn't hold, the same result doesn't hold if you use some other measure, I think that outcome, tells you something about to what extent you should be confident about your results, right? So if you're looking at document similarity and you find that your documents are only similar if you use one measure, but are not similar if you use 3 other different kinds of measures, then, I would be less confident that those documents were actually similar to each other, if that makes sense. So that tells me something about the stability of the inference, it tells me something about the inference that I can make from that process.
And kind of wheeling off that, we had a question about reproducibility and replication. Mm-hmm. And so it's a longer question, so I'm going to kind of cut down. Would you think, for example, that analysis of interview protocols of a select group, and in their case it's musicians at a university, using a word matrix could be replicated by another researcher? Is that something that we should expect, or is there more art than science in some of these instances?
I'm sorry, can you repeat the scenario again? So they're in an interview? Yeah,
so the text that they're looking at is analysis of interview protocols of a select group, and their select group is musicians. Okay. And using the word matrix. And so what sort of a
Hello?
I'm sorry, what sort of go ahead.
No, go ahead.
So what sort of research or reproducibility protocols have you encountered? Or not protocols, but examples or?
Yeah, so I guess for me, so there's both shallow reproducibility, and then there's sort of like deeper reproducibility, right? So the most shallow form of reproducibility should be if I follow the researcher's instructions on using the same tools and the same text, can I reproduce what it is that he or she did, right? So that's kind of like shallow reproducibility, i.e. if I use the recipe, do I end up with the same outcome? There's also, I think, which is more like fundamental reproducibility, which is if I replicate the person's process on a different sample, or using different data, or using a slightly different model, do I end up with the same kind, can I draw the same sort of inference, right? So that's less about if I follow their individual instructions and more about what's the generalizability of the finding? Does it work in sort of out of sample as well as within the process that the researcher themselves actually did? So if you're interested in sort of reverse engineering how did these protocols actually lead to this particular candidate being selected. I think that might be maybe more of the first one. Can I backtrack how people came up with a decision to hire a particular individual? But if you're trying to sort of back out, do these protocols help us understand getting desirable candidates, then you might want to also, you might want to think about like other kinds of samples that you could use. I think that's, if that helps, that's sort of like two different ways of thinking about reproducibility. So one is about the stability of the finding, whereas the other one's about the actual like internal construction of the research process. Like, did it work? Can I redo what the person said that they did?
So we've had a couple questions that kind of center on the idea that people on different sides of an issue may use some of the same language. So we had one question about negation, saying I'm not in favor of this, which then how does does our text analysis pick up that not aspect? And here's another question in that same vein that I'll read in whole. With the commentator criticizing inflation and a commentator criticizing commentators critical of inflation, would they not be at risk of using the same number of words, thereby making it difficult to differentiate between the meanings connected to the usage of specific words? And would a researcher not need to validate qualitatively observed difference?
Yeah, so actually this is something close to my heart. So in the paper that I showed you about inflation, one of the things that we then did afterwards is I took a random selection of statements that were made by individuals and a number of human coders, and we actually went through a random selection of sentences and made sure that the sentiment of the sentences. So when people talked about inflation, they were mostly talking about the risks of inflation rather than, the possible benefits, which would, of course, like compromise the validity of thinking about words. Definitely in the context of governments. So another question relates to another question often in government, sometimes especially in the UK, members of parliament can be sarcastic. So there's a whole sort of research literature in computational social sciences as well as in natural language processing that thinks about sarcasm. Sentiment can also sometimes get at negativity versus positivity. So those are definitely things that researchers think about. And there's a number of tools that you can either try to validate after the fact or alternatively try to model with your feature set in order to get at those things.
So we had a suite of questions that are all kind of focused on the overlap between quantitative and qualitative methods. And so one question is, can we use QTA mostly? Can it be used in mixed methods? Mm-hmm. Also, how words alone don't carry all the important meaning. What techniques do you see as helping in content or topic analysis on a computational basis? And then just to write out, how can quantitative text analysis be integrated with qualitative analysis? So I'm wondering if you could kind of, those three different questions, but if you could talk about that for a moment.
Yeah, so this is not something that I've done, but I'm kind of interested in thinking about how we can use for transcripts of interviews or other types of things as input data for quantitative text analysis. So maybe you have a bunch of participant interviews in focus groups or something like that, and then you sort of want to use the responses from the interviewees both in a qualitative sense and in a quantitative sense. So in that sense, you could be able to sort of marry the two in a more mixed methods type approach. So that's definitely something. In terms of actually including expert information or human judgment in these types of things, this is, I think, the point that I was trying to make with the social science expertise. So rather, I think what the social scientist offers in these kind of quantitative text analysis or computational social science in general is strong theories about the fundamental data generating process. What do we expect the key topics to be? What do we expect the key discriminating topics to be? That type of expertise is the type of thing that I think is really useful, especially if we can leverage it in such a way as to, better identify these sometimes hard to identify models. So I think the individual talked about a topic model. So a topic model is sort of a data description. It's a description of the data. It's unsupervised. The data sort of determines categories or topics for you, and then it's sort of up to you to label those topics. So there's a political scientist and a bunch of political scientists that came up with something called the structural topic model. And this is about actually including covariates, or things that we know, and including that information into the topic model to try and better identify the topic. And of course, that knowledge, that expertise comes from some sort of, theoretical or vocational knowledge that you have, which you then bring to the data. So I do think that, human judgment, human expertise is actually quite important in this kind of big data processing.
So you had talked a little bit about the differences in working with different languages and the structures of different languages. What challenges do you find in compiling and comparing textual data across multiple languages? For example, a data set with text from 10 different languages on the same topic.
Yeah, so I haven't actually done this. So I know that this is actually a really hot research topic, and again in computer science and then natural language processing. So you can do anything as blunt as to try and translate that language into a common language. So for instance, you can use some sort of translation, put everything in the same language. Sometimes organizations do that themselves. So this is actually, I think, one of the areas in which this is quite used quite frequently is to think about the European Union, because there you have a number of documents that are available in a whole bunch of different countries' languages, but then they usually also make an English translation of that document, and then so you can kind of use the English as a benchmark. Again, this is really active area of research. Some languages have more sophisticated tools than other languages, and that sort of depends on the development side. So Farsi actually has a number of NLP tools. Why? Because there's a number of people that work in that topic that also happen to speak that language. German is also very well supported. English is well supported. Chinese is quite well supported. Japanese is also well supported. But there is, to a certain extent, the supply of those tools is also kind of partially determined, at least by the people that are, and the interests of the people that are working on building those tools. So, but yeah, that's a hot topic, especially in computational social science, for sure.
So we've had a ton of questions, and we're not able to get to them all during this hour, but we'll hope that we can address some of them on our various blogs on MethodSpace and on the Sage Campus blog going forward, and especially as we post the recording of this. So I want to thank you, the audience, for joining us, and I want to give a special thank to our guest, Nicole Ray Baerg. In the coming weeks, again, expect an email that includes a link to the archived webinar and answers to some of the questions we not get to. I want to remind you about that discount code too for this course, and we got a lot of questions specific to the course, so I know that there's some interest in that. And that code, which is on the screen right now, QTAWEB50, applies both to the quantitative text analysis and all the Sage Campus courses. And I also want you to remember that there are 2 upcoming webinars on Sage Campus. One on R and the other on Python on March 7th at 4 p.m. GMT, which is 11 a.m. Eastern Time and 8 a.m. Pacific Time. Martin Hadley will be our guest in a discussion of interactive visualization with R. And the next day, March 8th, at that same time, Rob Mastro-Domenico will present a live Python session. So I want to thank you all today. I want to thank you especially, Nicole, and we'll see you guys in March.